Okay, let me check if that works. Yeah, my name is Olex. I'm lead of cryptography at Rarimo Protocol. I'm gonna make a quick intro how we came to proving something like client-side, and then make a small announcement what we're gonna do. First of all, everything started with passports. 1.5 years ago, we introduced zero-knowledge passports, where you can prove that particular data is included into the passport, the signature of the passport is valid, and additionally, you can make different queries on top of that. What is good? There is existing passport infrastructure. So dozens of million passports are issued already, and you don't need to reinvent the wheel. You can use the current biometric passport, you can extract the signature, you can extract all the data and transfer that in verifiable manner on-chain. And you can add a privacy with zero knowledge. So, for example, you can prove that you're Ukrainian or you're adult Ukrainian, but without sharing your name, surname, etc., etc. And that's very good criteria from the real world to Web3 applications. What kind of applications? First of all, you can prove that you're adult. Then you can be integrated with some zkKYC services. For example, there can be some policy that allows you to have access only in the case you have a particular citizenship. Additionally, you can prove that you are human. That's quite controversial because passport doesn't prove you're human. But government thinks you're human issuing this passport to you. Of course, you can build sybil protection applications. And additional interesting case, that's sanction list. You can extract the data from the passport and prove that you're not included into specific, for example, a FAQ list or some blacklist. You can provide different gifts based on the type of the community you're forming. For example, you can provide a free internet for Iranian women and do not know their specific data. You can build different social applications, and additionally, this is very hard to achieve, you can build applications that require uniqueness. Why uniqueness is hard to receive? Because first of all, people can have different passports, so it's totally eligible to have 2 or more passports. Additionally, you cannot extract the uniqueness from the passport in the private manner because there is an assumption that government knows everything. So, and if you can extract this uniqueness from the passport, it means the government can do the same and reveal your identity. But we launched a very specific solution. We launched a freedom tool. What the freedom tool is? That's a cryptographic solution for political problems. It doesn't resolve political problems, but at least it can initiate discussions around them. A lot of people think we have built digital voting, but I would rather say we have built a digital protest solutions because we cannot extract uniqueness from the passport, but for example, in some applications, you don't need a uniqueness. For example, if you're signing petitions, if you're supporting some protest, if you're doing some social questionnaires, you don't need to have this uniqueness. And we have tested this application in several countries, for example, Iran, Georgia, Russia, etc. Right now, we have a second version in production. We allow everyone to create their own questionnaire, their own pool, and select the criteria for the voters. That's completely open source, so you can find that, you can fork that, and you can launch your own instance. But people ask it how we can resolve one specific problem. The problem is how you can prove that you are an owner of the specific passport. Because somebody can steal that, somebody can, for example, government can issue millions of passports and vote instead of real people. And we switch it to kind of zkAI. What is that? We can prove that the distance between the picture included into the passport and the scan of your face under particular threshold. And definitely that's not deterministic algorithm, so that's not a digital signature that can be verified directly. That's some like model that can be executed with some like prediction, but you can calculate like the difference between these two results. So that's not 100% assurance, but at least, yeah, it's better than nothing, first of all, and it increases the cost of attack a lot. So you cannot like just print infinitive number of passports, because later you need to prove that right now passport is used by the person who like matches this criteria. Yeah, is the same like everything should be private, so you shouldn't reveal your like biometry data with some government or trusted issuer. You shouldn't like reveal your passport data. So ideally, all processes should be executed on your client device. And yeah, as always, we came with the framework. So yeah, with the passport, the same story. We resolved a particular issue, then came with a framework that allows you to fork this like passports and yeah, upgrade them later. We have built like the first version of Freedom Tool for one specific oppositioner, and then extended that for Freedom Tool version 2 that can be forked by anyone. And the same like was with this like zk AI. So we came with a framework that allows you to run different models like covered with zk on your client devices. And we call that Bayonetta. So what the Bayonetta is? First of all, it's a framework that allows you to build provable models. You can prove the distance between different objects. You can build a classifier that detects a particular object, yeah, in the world. You can build like the model that detects the liveness of the particular person. The next one, what like the main difference from existing frameworks, that's architecture of these models, and all weights, all parameters are open and hard-coded into the circuits. So for example, zkML, Lagrange, etc., they are hidden weights. In our case, yeah, first of all, you need to have like this provable model, because finally it should be verified by the smart contract. In this case, you cannot hide the specific architecture and weights. And additionally, we found out that it can reduce the amount of constraints dramatically. So that's R1CS friendly. So right now it works with gross 16, but we are switching to ultra gross. We have applied specific like quantization scheme, and additionally we did some layer specific optimizations. Yeah, how we have reached zk friendliness. As I mentioned, yeah, Bayonetta has R1CS arithmetization and additional hard-coded weights in circuits. And it allowed to reduce the amount of constraints from like 20 million for some models to only 1.5 million. Like to be clear, you can run some algorithm in the key form on your local device if it's like within 1 and 2 million of constraints, because it requires like a lot of random access memory. But if you have like these weights in a hard-coded like public form, it means you can do some like linear transformations for free. So all operations with like, for example, addition and multiplication by the constant in R1CS cost 0. And this approach allows you to have like very hard models that can be still executed on your local devices. Yeah, and having R1CS arithmetization, Bayonetta supports different like zk protocols, for example, Spartan, ultragross, Hyrex, etc., etc. So you can provide some TensorFlow or PyTorch in the future model, convert that with Bayonetta to like R1CS, and then prove that on your local device. Yeah, there are some like activation functions, so you cannot reduce the amount of constraints for activation functions because they're not like linear. But additionally, you can have some optimizations that allow you to have only like n or like 2n constraints for each activation layer. And you can see like our comparison table with other well-known frameworks for zkML. Why is this client side? First of all, like proof size, that's just like 6 like points. So that's gross 16 verification, so that's very cheap. Verification key is the same. It's like very easy like to generate that. Proving time, yeah, it depends on the model actually, because the larger the model, the more like resources and time you need for that. And verifying time, that's also like 3 parent operations, and that's it. Probably from the client-side perspective, only Lagrange has like more performant solution, but as you can see, they have a dramatically like big proof size. It cannot be verified by Ethereum natively. You can wrap that with, for example, snarks or like other or with plonks, but anyway, that's not client-side already. We have built different models. For example, we can detect the liveness. As you see, sometimes the model works better than we expected. It can detect if some contact or if some person wasn't generated by some AI, that's like a real person, etc., etc. We can build classifier, and it can detect if a particular animal in the front of the camera. And for example, you can program your account the way it can be recovered with a cat. Additionally, you can build the same model for different objects. So you can create a recovery method for your account that requires not the knowledge of your seed phrase, but the knowledge of the specific object. For example, some specific page in some specific book, etc., etc. Yeah, you can investigate more how Bayonet works with the list of resources. And yeah, we're gonna like publish everything open source, probably, I don't know, in 2-3 weeks. But if you wanna check how it works right now, yeah, please contact me. What's the next? Yeah, we are playing in kind of Harry Potter, and we wanna like remove seed phrases in all wallet solution. How it can be done? As I explained, you can extract the uniqueness from like different objects and reuse that as a secret data for your account. So you can derive key materials from like different from like environments. And right now we are working on fuzzy extractors that allows you to receive this uniqueness from objects. What a fuzzy extractor is? This is like some between cryptographically secure hash function and a model that operates with the objects that have like high entropy. Fuzzy extractor allows you, as I mentioned, to receive the uniqueness from like different objects. And first of all, yeah, you can prove that, and additionally, you can recover key material from like any object. We have some intermediate solutions that doesn't like compromise the security for access into your account, but at the same time, you cannot build a fuzzy extractor with like, for example, 128-bit security. But we are additionally applying other like cryptographic methods to have this 128-bit security. And long-term plan that people shouldn't remember seed phrases. If you have like a secure method of deriving the key materials from like any object you know, it means you cannot lose an access to your account. And yeah, that's like only early stage of building that, but if you want to like have an access to the repo, for example, yeah, feel free to reach me. That's it. Thank you very much.
Thank you so much. Does anyone have any question? Okay, well...
Good. Thank you again.
Thanks. Oh, there's one.
I can ask about the growth construction. We have, as far as I remember, it has a trusted setup.
Yes, it's a trusted setup.
So who knows that and how it's generated? And are you planning to go to Plonk or should
we can use Plonk, but yeah, potentially. But it's you cannot do such optimizations with Plonk. As I mentioned, we applied the method that allows you to have all weights publicly hard-coded into the circuits. And it leads to all constraints with multiplication and addition, the constant will cause 0. This Plonk arithmetization works differently, and you cannot reduce these constraints with Plonk. So this is the reason why we are using R1CS. So potentially, yeah, the trusted setup is a relevant question for all projects that are like building on Gross 16. But yeah, this procedure can be decentralized, so yeah, I don't see any problem with that.
Well, okay, thank you so much.
Thank you
Another
again.
round of applause for him, and see you at 4:30.